Well, it gives me a great deal of pleasure, and it's an honor to present someone who really does need no introduction to this conference. I'm sure everyone here knows the work of David Chalmers. I won't say much now. I'll say a bit more by way of introduction in the second part of this morning's festivities. So without further ado, here's Professor David Chalmers, and he's going to talk to us about what happens when Zeno goes to Copenhagen.
Thanks very much, Bill, and thanks very much to Harold and Stu and everyone else involved in putting this conference together for the extremely interesting conference. In the early stages of the conference and the speakers and so on, I noticed there were quite a lot of people here interested in physics and quantum mechanics and so on. So my talk today is going to be about some themes connecting consciousness and quantum mechanics. I should say all of this, the work I'll be presenting is entirely co-authored with Kelvin McQueen, who was formerly a student of mine at the ANU and now teaches at Chapman University in California. I know the title is maybe a little bit opaque, but the Copenhagen in the title is, of course, a reference to the Copenhagen interpretation of quantum mechanics. The subtitle fills it out just a little bit more. The subtitle is a dilemma for measurement collapse views of quantum mechanics. So just to spell out a little bit of background, Copenhagen, as anyone who knows a bit about the foundations of quantum mechanics knows, the word Copenhagen interpretation is used for a million different views, many of which are incompatible with each other. However, there's one common usage on which the Copenhagen interpretation is just used to refer to the idea that there's a quantum wave function which collapses on measurement. A very simple idea about the connection between wave functions, measurement, and collapse. That's the way I'm going to be using it today. So Copenhagen interpretation, an extremely orthodox, if often rejected, interpretation of quantum mechanics where there's a wave function that collapses when it's measured. Why is that interesting at a consciousness conference? Well, there's a somewhat more specific idea that's often thrown around and speculated about in the vicinity of this measurement collapse idea. This is the consciousness collapse idea. This is not equivalent to Copenhagen. You can believe that measurement causes collapse without understanding measurement in terms of consciousness. But it's at least many people have been very tempted to embrace the further understanding that that understands measurement in terms of collapse and go for a consciousness collapse interpretation. And that's one of the ideas that Kelvin and I have been pursuing in our work on this the last few years. Maybe 4 years ago at Helsinki, we presented a talk on this general idea that consciousness collapses the wave function. But towards the end of that talk, we said, well, there's a small little issue with the quantum Zeno effect. So the Zeno here only has a distant relationship to the Zeno of Zeno's paradox, where nothing could move from A to B because it always had to get halfway first. But there's a tenuously related phenomenon in quantum mechanics called the quantum Zeno effect. Basically involves the fact that making certain observations too frequently stops various quantities which are being observed from changing. Anyway, Kelvin and I noticed that the quantum Zeno effect seemed to raise a fatal problem for the consciousness collapse interpretation we were developing. Since then, we've come to think that actually the quantum Zeno effect raises a quite general problem for the broad class of Copenhagen-style measurement collapse interpretations of quantum mechanics. So that's what I want to articulate today. So an overview, the Copenhagen interpretation, as I've said, a view of quantum mechanics where measurement collapses the wave function. we're going to argue that Copenhagen raises a dilemma arising from the quantum Zeno effect, a quite serious one. There may be some options for solving it, and towards the end, I'll go through some of those options. But first, I'll go through some background about consciousness and about quantum mechanics. I'll introduce the Zeno effect and the problem, and in the last part of the talk, I'll look at some possible options for solving it, including the option that we're right now exploring. All of this is exploratory. I'm certainly not endorsing the views here, in fact, raising problems for them as much as anything else, but I think they're views worth exploring. Okay, so background. Let's step back. Consciousness. What is that anyway? Consciousness, or phenomenal consciousness, or subjective experience, or sentience, or qualia, all of which are at least fairly close to being interchangeable as I use them, all of which are referring roughly to what it's like to be a conscious subject, what it's like to perceive, to feel, to think, and so on. I take it that concept is familiar to most people here. And it raises, consciousness famously raises a problem. How and why the physical processes give rise to consciousness. It looks like physical processes are great for explaining behavior and functions, the so-called easy problems of consciousness, how systems respond, how they do things, but they don't look so great for explaining subjective experience. That's the hard problem. How do these physical processes give you subjective experience? Great at explaining functions, but leave a gap to experience. And in a bunch of previous work, I've argued this is at least fatal for various forms of reductive physicalism in explaining consciousness. But a few views are left open. Some of the views which I've been, over the last 5 or 10 years of my own work in thinking about consciousness, I've been mostly trying to be somewhat constructive on these issues, looking for what actually are the options left open, trying to explore them and develop them in depth. But of course, each of them faces very serious problems. In fact, what I find is that whenever I think about a view of consciousness for too long, I'm very naturally led to reject it. So when somebody asks you, what's your view of consciousness these days? It's whatever view I haven't been thinking about too much recently. But some of the views I've find somewhat, among the more promising options include, various extremes, actually. If I was to be a materialist, the view which I find at least intriguing is illusionism, the view that consciousness doesn't exist, but somehow it's just an artifact of our self-models that make us believe in this thing that doesn't exist. It's a view associated with Dan Dennett and Nick Humphrey and others. It's just got one small problem, which is it's totally impossible to believe and appears to be inconsistent with certain fundamental data that we have. The view does predict that it's impossible to believe, so maybe that's something to be said for it. But anyway, that's one option. Another option, panpsychism. Consciousness is everywhere. It's got a famous problem named by our chair, Bill Seeger, the combination problem. How do those little bits of consciousness add up to our consciousness? Those aren't the views I'll be talking about today. The third option, and one that's received somewhat less attention, I think, in recent years than panpsychism, but is a much more traditional option in Western philosophy, dualism. Consciousness is non-physical. There's physical stuff, there's consciousness, never the twain shall meet, but then the problem is, how do they interact? That's the famous problem of interaction. And dualism comes in two forms. Epiphenomenalism, physical processes cause consciousness, but not vice versa. Scientifically simpler, but it's got this big problem. If consciousness plays no causal role in the physical world, how am I even standing here giving this talk all about consciousness with consciousness playing no role? That seems to many people more than faintly bizarre. The other kind is interactionism. Physical processes cause consciousness and vice versa. More intuitively attractive, perhaps, but it faces the big problem of how is this consistent with the apparent closure of physics. Anyway, it's interactionism I'm focusing on today and consciousness collapse and so on is of interest here largely because it offers a possible solution to the interaction problem. Of course, Descartes was an interactionist, and he thought that the mind and the brain interact through the pineal gland, deep between the hemispheres of the brain. You get some signals through your eyes and up to your visual cortex and so on, and eventually the brain sends a signal to the mind that does some thinking, then acts back on the brain, and you get an action. This is the picture of interactionist dualism. Some stuff happens in the brain. At a certain point, that affects some things in the non-physical properties of your mind, which then at some point have some effect back on the brain and cause an action. And the question has always been, how does that work? How can you reconcile that with things like the apparent causal closure of the physical world? And many people say physics totally rules this out because it's causally closed. But then if you look closely at physics, and in particular quantum mechanics, there seems to some people to be this one big loophole in physics, one big giant gaping hole where there's room, perhaps, for something outside the system to play a role, and that's in quantum mechanical collapse. So many people have been led to speculate. Most famously, Eugene Wigner, in his piece Remarks on the Mind-Body Question in the early 60s, that consciousness is what's responsible for wave function collapse, plays a causal role in the physical world by bringing it about. Henry Stapp has developed the idea more recently. It's conscious observation that collapses a superposed wave function onto a definite state. So let me just sketch a tiny bit of background about quantum mechanics. We've already talked about this quite a lot at the conference. Okay, so this is a picture of the consciousness collapse idea. And yes, it looks a little bit spooky. So, this idea of consciousness collapsing the wave function doesn't have the greatest reputation, I think it's fair to say, among either philosophers or physicists. Still, I think it's an idea that deserves to at least to be explored with rigor and detail so one can see its advantages and disadvantages. So here's a picture I found on the web of quantum mechanics. We standardly do quantum mechanics with wave functions representing the world, evolving according to the Schrödinger equation, and somehow, as a result of all this, nonetheless, in our observations, we observe a classical world. How do you get from one to the other? Well, a very orthodox picture is that somehow this wave function has to collapse to give us our conscious observations. So, just a little bit about the wave function. In classical physics, systems are described by definite values. Particles have definite positions. Its position is specified by a definite location. In quantum mechanics, systems are described by wave functions. A particle position is not typically specified by a single value, but a wave function with different amplitudes for different locations. So there's a little picture. The top ones are classical. The bottom ones are quantum. These have a definite location. These have a wave. Typically, the wave function for, say, a particle's position will specify a bunch of positions with non-zero amplitude at many positions. Then we say the particle is in a superposition of different positions. And there's certain standard principles for dealing with quantum mechanics. The big central thing is the Schrödinger equation. Gives you an equation for how this wave function evolves. It's a linear equations. Things tend to evolve in superpositions. Then there's something called the measurement postulate. When you measure an observable, like position or spin or whatever, it takes on a definite value, probabilistically based on the wave function with probabilities given by the Born rule, so that you get a definite result for your measurement, and after the measurement, you treat the wave function as having collapsed into a more determinate state. So, previously the wave function of the particle's position is like that, you measure it, turns out to be there. Now the wave function collapses into a much more definite state, something like this. It's a spread out wave function. Make a measurement, you get definite wave function. That's at least a very, very standard formalism for quantum mechanics. Leaves open the questions of what's going on in reality, what we should take this theory to be about and what it's saying about the world. But there's a very natural class of interpretations, the ones I call measurement collapse interpretations that just say, take the standard dynamics at face value as a picture of objective reality. The objective state of the world corresponds to a wave function. The wave function really evolves according to the Schrödinger equation, and it really collapses on measurements. So it just says, take those standard principles, view them, and accept them as dynamics of objective reality. This is sometimes called the Copenhagen interpretation of quantum mechanics. Now, as this picture makes clear, don't worry about the details, there are a million things called the Copenhagen interpretation of quantum mechanics. I think probably it should most properly be reserved for the views of Bohr and perhaps Heisenberg, who developed a rather complex and obscure conceptual apparatus of complementarity and other such notions that not many people have been able to understand all that well. Still, but there's also a tradition, I think especially among physicists, of using Copenhagen just to mean this idea that there really is, there's a wave function, it really evolves, it really collapses. That's how we'll be using it here. It's also sometimes used for a general view of the kind of shut up and calculate kind. Quantum mechanics is a great formalism for giving the results of the experiments. Don't worry about reality. Anyway, we're using it the first way here, mostly because we couldn't resist the title of the paper. So what the hell? Go with Copenhagen. So that's the measurement collapse interpretation. Of course, there are many other interpretations of quantum mechanics, and we're not rejecting them or even arguing against them here. The Everett-style many worlds interpretation, David Bohm's hidden variables interpretation. Chris talked about quantum Bayesianism or cubism the other day, a more subjective interpretation of quantum mechanics, and there are even other collapse interpretations. Girardi, Rimini, Weber have a spontaneous collapse interpretation. Wave function collapses, but not for anything to do with measurement. Pearl has another I'll be talking about. And Roger Penrose earlier talked about his space-time triggered collapse interpretation. Again, there is collapse, but it has nothing to do with measurement. These are all interesting ideas. We're actually sympathetic with a number of them. Not going to criticize them today, but we're just going to take the Copenhagen idea, the measurement collapse idea, and run with it. There's an objective wave function. Describes objective reality. It really does collapse on measurement. Raise some problems and see what sense we can make of that view. Now, there's a very standard problem for measurement collapse, and that's the problem, what is measurement? People call this sometimes the measurement problem. The ordinary notion is completely imprecise, somewhat anthropomorphic. Who can make measurements? Is it just people or dogs or measuring devices? How could such a imprecise notion as that play a role in fundamental physics? And people sometimes say that's a decisive problem for these views, but I think there's a very natural reaction, which is, well, when something's imprecise, then, well, as we say in philosophy, precisify it. Find a more precise thing that can play that role. Okay, here's the problem. Here's Schrödinger's cat. There's a particle decays, and it's connected to some chains and some hammers and a bottle. And where along the way is a measurement made? And where does the wave function collapse? Is it as soon as the particle decays? Is it with the lever? Is it with the bottle? Is it when it hits the cat and the cat makes an observation, or is it only when the human opens the box and looks at the cat? Well, there's one idea here that many people have been tempted by. The one non-arbitrary criterion for collapse is consciousness, that somehow it's consciousness that brings it about. And as I mentioned, Wigner has put this idea forward. People say they can find it in von Neumann and London and Bauer earlier on. Other people have looked in this direction. It's at least a way of getting a bit more specific about what causes collapse. Measurement is just conscious observation. This view goes, this helps a lot if you combine it with the additional claim that consciousness is by its nature precise. Consciousness is either present or absent. Josh O'Rourke gave a talk in the concurrence yesterday arguing for precisely that view. You can't be in a state where consciousness is kind of borderline or neither there nor not there. It's always either on or off, even if it varies when it's on, and it's in a precise state. you can combine this with maybe a precise theory of the physical basis of consciousness. So Kelvin and I have worked in this context with Tononi's integrated information theory, just because it's a relatively mathematically precise theory. It has problems of its own, but it gives you relatively precise principles for what configurations give you what states of consciousness. And then we get some relatively clear and precise criteria potentially for collapse. And of course, consciousness collapse views, some people object to consciousness collapse views on the ground that it's treating consciousness as fundamental and playing a role in fundamental laws, and that's awful because it's dualism. Well, maybe in some contexts, if you're antecedently disposed to reject dualism, that'll be a problem. In the current context, where we're actually exploring the prospects for forms of dualism and dealing with the objection that could it play a causal role in the physical world, this objection doesn't carry too much force. In fact, the dualistic view of consciousness and the consciousness collapse view can somehow be seen as mutually supporting. So the consciousness collapse view has a couple of very big potential advantages. It's a version of measurement collapse that yields a precise interpretation of quantum mechanics and gives a causal role for consciousness in the physical world, but also faces a very big challenge, which is just turning it from an idea sketch into actually a fully fledged theory with a very precise dynamics. And I'm not sure that anyone has really done that, so that's something that Kelvin and I have been trying to work on, make the dynamics of a consciousness collapse view clear and precise. In our talk at Helsinki, which is now a paper, Consciousness and the Collapse of the Wavefunction, again with the proviso that all of this should be getting, which is we're not actually endorsing any of these views, we're just exploring them. We talked about M-property dynamics, and I don't want to go too much into all the details of the view we were developing, but the rough ideas the general approach to measurement collapse theories, there are certain special properties, maybe properties of brains or measuring devices or whatever, that resist superposition, that never enter. The extreme version says they never enter superpositions. They have to stay in a definite state. Maybe certain properties of your brain and the neural correlate of consciousness, somehow that's constrained to being in a definite state. When it would evolve into a superposition, instead it stays in a definite state, collapses everything they interact with. And then the idea was maybe then that's just one idea, but then take the further step of saying maybe consciousness is an M property. Consciousness is a property that resists superposition. Your consciousness is always in a definite state. When your brain would evolve into a superposition that gives you multiple states of consciousness, got to choose one. Consciousness is definite, and it collapses everything else that the correlates of consciousness are entangled with. So that was kind of a cool idea, we thought, but it runs straight into the Zeno problem arising from the quantum Zeno effect. And I'll just first give you the kind of the upshot of the problem before talking about the details. Roughly, if you've got these absolute M properties that can never superpose, it turns out they can never change. It's just a general property of quantum systems. You've got properties that can never enter superpositions. They can never change by Schrödinger evolution. I'll talk about the reasons in a second. So if consciousness is an absolute M property, it turns out your state of consciousness can never change, which is a small problem. I mean, you might worry, for example, consciousness has to get started in the early universe. Start from a point where there's no consciousness, the first conscious creature must evolve. At some point, a change in consciousness. But according to the Zeno effect, the moment the first conscious creature blips in, it's going to snap, the wave function will collapse back to a state of no consciousness with probability 1. Worse, if you're napping right now out there in the audience and you're out, you might be hoping to wake back up in a minute and return to consciousness. Well, quantum Zeno effect says, nope, that's not going to happen. You're going to stay in your nap, not just until spring, but forever. Why? Because, again, that would require going from a state of unconsciousness to a state of consciousness. If consciousness can never enter superpositions by Schrödinger evolution, that can't happen. This bear is going to stay stuck in a state of unconsciousness forever. Okay, serious, potentially fatal problem for that view. And so we thought, okay, that absolute M property view is clearly a non-starter. But fairly soon after that, we realized, okay, well, there's actually not, I mean, the M property theory is just a specific version of a consciousness collapse view, which is itself a specific version of a measurement collapse view. So measurement collapse theories are doubly more general. But we noticed that, in fact, this quantum Zeno effect actually seems to raise an analogous problem for measurement collapse theories of quantum mechanics quite generally, these Copenhagen-style views I've been talking about. And the Zeno problem only has a fairly limited range of solutions that heavily constrain any Copenhagen-style view in really quite surprising and interesting ways. And that's what the rest of the talk will be about. I mean, here's a way just to put the problem just semi-formally. I mean, the measurement collapse view says roughly that a system collapses onto an eigenstate of an observable precisely when that observable is measured in that system. So let's represent that by saying MSO. M of S and O just says observable O is measured in system S. Typically, it'll be measured by some other system, S prime, but I don't think we need to mention S prime here. It's just saying that observable is measured in this system. Then the measurement collapse view says the wave function of S collapses onto an eigenstate of O if and only if MSO. So MSO here just represents the conditions for collapse. And one could actually do this for any account of conditions of this form, but it's natural to understand it in terms of measurement. So a question that gets this Zeno dilemma going is measurement itself, is this thing MSO itself a quantum observable? Now, the concept of a quantum observable is a somewhat technical and specific one that gets cashed out in terms of Hermitian operators, and I'm not going to go into the mathematical details, but the cache value is most intuitively measurable quasi-classical properties correspond to quantum observables. Things like the location of a particle or the shape or the configuration of a system, most functional properties, most computational properties, and so on can be regarded as complex observables. And it's very natural to think that measurement itself is a quantum observable. I mean, one way to think about this question is, can measurement itself be measured? Are there sort of standard measurements you can do to see if one system is measuring a certain observable in another? And it's very nat on most, say, classical cognitive science conceptions of measurement, it's absolutely going to come out to be measurement will be measurable, measurement will itself be an observable. So prima facie, you would think that measurement would be an observable. It looks like you can perform observations to determine whether one system is measuring another. But if measurement is an observable, then we walk straight into the quantum Zeno dilemma. And to raise that question, we now say, okay, once you've got a quantum observable, well, any observable can enter standardly observables themselves enter superpositions and can be collapsed by measurement. So now we can ask, can measurement itself enter superpositions? We're not talking about measuring something else. Now we're talking about measurement itself. Let's say we define up MSO to be an observable that has a certain value, +1, if a measurement's taking place, -1. If a measurement is not taking place, can that thing enter superpositions? Can the wave function of the world, if you like, be in a superposition of measurement, this observable is being measured, and this observable is not being measured? O is being measured in S, and O is not being measured in S. Well, the dilemma is that either option seems to lead to pretty serious problems. First horn of the Zeno dilemma is that if measurement can enter superpositions, it looks like the dynamics is ill-defined. I mean, the Copenhagen dynamics says collapse happens if and only if measurement takes place. It says if the observable is measured, if this observable of the system is measured, collapses. If it's not measured, doesn't collapse. And it's binary. It doesn't have room for shades of gray here. If you're in a superposition of being measured and not measured, there's a superposition of collapse and no collapse. That is no part of a standard measurement collapse view. It seems like we would have to, at the very least, extend the theory with a whole bunch of extra principles to govern what would happen when the system was in such a superposition. It's as bad as this Dilbert cartoon where the project exists in a simultaneous state of being totally successful and not even started. Very, very tricky whether one can actually observe measurement. It would give rise immediately to this problem. Okay, so you might want to say, okay, measurement can't enter superpositions. That's the second horn. But if measurement is an observable that can't enter superpositions, then measurements can never start or finish. That's the quantum Zeno effect. This is just a more generalized version of the problem mentioned for consciousness earlier. So let me just say a tiny bit about the Zeno effect with all formalities left aside, as throughout this presentation. It roughly says if you measure an observable too often, it'll be slow to change. If you continuously measured, say, the position of a particle, that's called a strong continuous measurement, then it turns out the particle won't move. It'll freeze. If you just measure it often, it'll move very slowly. So yeah, continuously measure an electron's position, it'll be frozen in place. Okay, fine, that's not being applied to measurement, that's other observables you're mentioning. So it's kind of, I like this thing. It's like here is Neo. How does that bullet time thing work in the matrix anyway? Well, it turns out Neo is exploiting the quantum Zeno effect. He's got access to the wave function. He's collapsing the position. He's observing the position of the bullet very, very frequently, and thereby making the bullets move very, very slowly. And it's also sometimes called the watch pot never boils effect. The guy is staring at the kettle and collapsing its boiling status constantly, so it never gets to start boiling. But now let's apply. Normally we do this for thinking about other things being measured, like position, temperature. But what if measurement itself was being measured? If measurement can't superpose, and it's as if measurement is being continuously measured. So you've got a system which is not measuring. It's like, is it measuring now? Is it measuring now? Is it measuring now? Is it measuring now? Nope. The measurement never gets to start. And if a measurement has started, likewise, it would never get to finish. I mean, the math you need here is actually very simple. All you basically need is math that says for an observable to evolve from one definite state into another via Schrödinger evolution, it has to pass through superpositions. So if you've got one that cannot pass through superpositions, it can't change in value. And then so measurements could never start or finish. So that would be a serious problem because it looks like, to get this whole measurement collapse framework off the ground, measurements have to start or finish. So here is let's sum the problem up with what philosophers would call an inconsistent tetrad. 4 claims inconsistent with each other that nonetheless all might seem fairly natural for this Copenhagen style view. You have to decide which to reject. Measurement is an observable, a quantum observable. I made a prima facie case for that earlier. Measurement is non-superposable. Well, again, because if it was superposable, the dynamics seemed ill-defined, potentially incoherent. 3, measurement is changeable. Measurements can start or finish. 4th, if an observable is non-superposable, it's not changeable. That is, if systems can't enter superpositions of a certain observable, they can't change their value of that observable. 4 is basically a mathematical fact about Schrödinger evolution. 3 is just a very obvious fact. So if you're going to reject anything, it probably has to be 1 or 2. There are some fancy things you can do to try to reject 2, but all would involve, I think, some fairly radical revisions of the Copenhagen style view, radical revisions and extensions. So I think actually the most promising view is that although it initially seemed intuitive to say measurement is a quantum observable, actually you should reject that view. And there are a few different options for rejecting that view. So I think the most natural option is to say, okay, measurement is something special. It's not a quantum observable. But then, what is it? I think there's roughly 3 options. Measurement is a classical property, measurement is a non-physical property, or measurement is what I'll call a wave function property. And I'll just explore each of those briefly. If you're really a traditional Copenhagen person in the Bohr and Heisenberg mold, you'd find them saying things like, well, there are quantum processes and classical processes, and these are distinct, and the measurement apparatus must be treated as classical. So if you tried to take that with ontological seriousness about objective reality, you might say, well, the world contains both quantum and classical process. Measurement is a classical process, and so not subject to quantum laws, such as QZE, and as I say, maybe there's something in the idea of complementarity that tends to suggest that. So you might think, can we extend that into a treatment of the measurement collapse dynamics here? I think the trouble is that for this to work, I mean, Bohr and Heisenberg were not Copenhagen theorists in the kind relevant here. They didn't think the wave function existed objectively and collapsed and so on. For them, this was all pragmatic. Regarded as a theory of fundamental objective reality, this will require an objective and precise distinction in fundamental reality between quantum and classical processes, which I think can't really be found. All there is in fundamental reality on this picture is a big quantum wave function. Classical processes gradually emerge from quantum processes at a non-fundamental level via decoherence and perhaps via collapse, but this is a pragmatic distinction made for practical purposes. So you've got to work through a few different options here, but I think mere classicality can't serve the purpose of being fundamental criterion for somehow, because basically this observable is going to end up being subject to strong continuous measurements, and it's very hard to avoid that. A more promising option, and maybe more relevant here, is to treat measurement as a non-physical property. I mean, both this option and the last are instances of what we might call dualisms of systems. There's measurement and there's the systems you measure, and there are fundamentally different kinds. I just mentioned quantum classical dualism, but now there's mind-body dualism. You might say, okay, very, very natural. For us, Wigner was himself a mind-body dualist. Measurement is an act of consciousness and is a non-physical process, so it's not subject to quantum laws like QZE. Okay, so that's fine as far as it goes, but it turns out you can raise the QZE problems even for dualism. For any version of dualism on which there's a precise physical correlate of consciousness. Let's call that a physical observable P with distinct states, distinct eigenstates corresponding to distinct states of consciousness. As on even most property dualistic theories of consciousness have correlations between brain states and consciousness. If you have those, you still get the QZE problem. Basically, call the physical correlate of consciousness the PCC, if the PCC can enter superpositions, then consciousness can enter superpositions, and the measurement dynamics will be ill-defined all over again. For the same reasons, if the PCC cannot enter superpositions, then its state can never change. So consciousness can never change, and we'd have the same problem all over again. So mind-body dualism doesn't help unless you go for a very strong form of dualism that rejects precise correlations between brain and consciousness, rejects the idea of there being a PCC, a precise physical correlate of consciousness. Consciousness would have to vary independently of the underlying physical state. And I think Henry Stapp's view of consciousness, he certainly does have a dualistic view and a very strong amount of quantum mechanics. He doesn't really address the Zeno issue, but he does seem to believe that consciousness can vary independently of underlying physical states. He has these primitive free choices of what to measure and so on. So maybe Stapp is prepared to go along with strong dualism and thereby avoid the problem. But it's certainly a very radical form of dualism, stronger than, I'm interested in dualism, but that's stronger than I'm willing to accept without a whole lot of very good reason. You need a whole new non-physical dynamics of the evolution of consciousness in its own right, independent of physics, to go along with this. And it still turns out to be very handled to handle cases of causation of consciousness by superpositions. Your visual cortex, you see a superposed particle, your brain, your visual cortex in a superposition of red and green affects the brain. The brain now is seeing red. Well, does that just collapse the cortex back into red and green? How does this avoid the Zeno problem? Anyway, so yes, dualism could avoid the problem, but it would require very, very strong form. The third option, the one that we're most inclined to explore, is that measurement should be regarded as a wave function property. It's not one of these quantum observables that enters superpositions and so on. Rather, it's a property of the wave function as a whole. And there are such things. In quantum mechanics, you take like the spread of a position wave function, or the property that having a superposition of a certain kind, or something like the degree of decoherence of a wave function. These things don't enter superpositions. They're properties of wave functions themselves. And I think this has the potential to avoid the problem. Here's a property of the wave function. The trouble is that our intuitive ideas of measurement don't behave like this, so it requires a non-intuitive notion. Interestingly, the closest analog for something like this in a bunch of existing theories, I think, is Roger Penrose's idea about space-time structure. Penrose and Stewart are not consciousness collapse theorists or measurement collapse theorists. They think there's an objective process of wave function collapse has nothing to do with measurement or consciousness. But Roger's view is that it's triggered by a certain kind of wave function property. Collapse is triggered when space-time structure becomes too superposed. You've roughly got this one graviton criterion for degree of space-time superposition that serves as the trigger for collapse. It's not a measurement collapse view, but it does avoid the Zeno problem. So here I'm going to take Roger as some inspiration for a measurement. Here's Roger's view. Here's Roger himself collapsing the wave function. That's how I like to think of it. Space-time gets in superpositions of these two states. That can't happen. Something has to collapse. Okay, but let's take Penrose's idea and mash it up with the M property idea and the measurement collapse idea with approximate M properties, those precise neural correlates of consciousness that previously they resisted superposition. We've got these special M properties associated with measurement, maybe physical correlate of consciousness properties. The absolute M properties, any superposition collapses. Approximate M properties, as M properties become more superposed, collapsed becomes more probable, Penrose style. Or at least that provides a rough image for what's going on. And I think you can actually combine this. You can combine this with many, many different theories of what, say, the physical correlates of consciousness are. But let's run with Tononi's integrated information theory, where the PCC, Tononi has this value phi, that it's a degree of consciousness. He also has a more complex thing he calls Q shape or qualia shape, which is the precise correlate of states of consciousness. Different Q shape, different state of consciousness, which is great. It's just what we need, so let's run with it. Well, this would work for other views too. Then we'd have a PCC observable, like Q-shape observable, different state for each state of consciousness. And let's say that resists superposition. We'll run with Q-shape. But instead of making it an absolute M property, we'll make it a approximate one. So then you'll get Penrose style. So now what we're doing, Stewart is guaranteed. What's that? Yeah, okay, yeah, getting maybe 5 minutes. Stewart is guaranteed not to like this, a mashup of Penrose and Tononi. But the rough idea is just where Penrose says wave functions collapse on superposition of space-time. Now we can say consciousness collapses on sufficiently large superpositions of Q-shape. So small superpositions of the PCC yield small superpositions of consciousness. Larger superpositions tend to stochastically collapse. Superpositions of Q-shape may collapse proportionately to, say, the degree of wave function spread or some other measure. Now, Roger doesn't actually have the dynamics of how this works, but there is a related idea that Philip Pearl has put forward that has a more precise and rigorous dynamics here. In a somewhat different context, Pearl has a continuous spontaneous localization theory where there's basically continuous ongoing collapses of things onto a position basis. Position is stochastically localizing according to a certain very, very nice stochastic differential equation. So now we're going to, so if you mash up CSL, but now with the M property idea, instead of saying position stochastically localizes, go with Q-shape stochastically localizing according to Pearl's dynamics. And it turns out you can do that if there's a distance metric on Q-shape, which there is. Then you'll get the physical correlate of consciousness gradually collapsing towards a definite state with the Born probabilities. Okay, so here's the picture as a whole. You might think, okay, something has got to have gone wrong here. We've got a mashup of Wigner and Penrose and Tononi and Pearl, and those things just shouldn't go together. So nonetheless, that's, I think, the most attractive picture I can see coming out of this that avoids the Zeno dilemma. The basic principles are simple. One is you've got kind of a mind-body connection principle that says, basically outlines precise physical correlates of consciousness. So Q-shape, certain Q-shapes go along with certain states of consciousness, and that's both directions, physical to mental, mental to physical. Normally, the physical stuff evolves according to Schrödinger equation, Q-shape evolves, you get a state of consciousness, but consciousness stochastically resists superposition. Idea may be inspired by Wigner and Penrose, but we spell out the ideas, we spell out the details with the dynamics of Pearl. Consciousness stochastically resists superposition and thereby collapses the Q-shape onto definite values. Observation. When you observe a superposed particle, when someone observes a superposed particle, say position A or B, their PCC will become increasingly superposed. Consciousness will stochastically collapse to a more definite state. That will bring about collapse of the associated PCC and entangled physical processes, and that will itself cause actions. Like, for example, collapse onto A state, state A of the brain will cause the action. The particle is in position A. So hallelujah, consciousness is actually causing behavior as we wanted it to do. Okay, so this last part of the talk on the positive view is really just, I thought merely having a negative result would be a little bit depressing, so it's nice to have a positive view on the table. That said, there's a million issues for it. I'm not going to go through them now. How can consciousness be superposed? Does it play the right kind of causal role? How are you going to set the parameters to avoid the Zeno effect just right and to maintain empirical plausibility? How do you make it relativistic? How to get, I think this is empirically testable, but it's very, very tricky to empirically test it. Anyway, but those are some questions we addressed in the paper on the positive view. For now, then, I think I'm out of time. So let me just sum up by saying, I think the moral of the Zeno dilemma for consciousness collapse views is only a very constrained range of views are going to work. Either a view with no physical correlate of consciousness at all, strong dualism, independent variation of the two, or one of these strange wave function physical correlates of consciousness, as on approximate M-property theories. And it turns out even for this measurement, much broader class of measurement collapse theories more generally in the Copenhagen mold, even those need either some form of very strong dualism to work or to treat measurement as a wave function property. I think that's interesting. It means that these theories have to be somewhat more constrained, I think, than many people have previously thought. It does leave some hope, but the hope is, it's small. It's not easy. I mean, the moral of nothing in the field of phenomenal consciousness is easy, but it's certainly not easy to be a consciousness collapse interactionist. However, there is at least a research program of developing, refining, and testing consciousness collapse interpretations. So maybe this is not entirely ruled out. It's left some small hope for a causal role for non-physical consciousness in the physical world. Thank you very much.
Okay, well, we have some time for questions if people will line up at the microphones, and we'll take 8 minutes or so of questions, and then we'll move on to a rather special event. Yes, please, sir.
Yeah, I'm trying to wrap my head around this. I thought it was really, really beautiful. And I just wanted to see if I understood you correctly, that what happens is that there's a sort of, instead of a gravity tension that makes objective collapse, that there's like a tension in consciousness that collapses the wave function, and it can also be the other way, so it's like a two-way street. Was that correctly understood?
Roughly, yeah. So take the analogy with, in Penrose, I guess it's a gravitational effect. Space-time structure gets two superposed by his one graviton criterion, and then you get collapse. So let's not go with that idea, but let's extend that to, let's make it work first with some physical correlate of consciousness. The physical correlates of consciousness resist superposition in a similar way. If your brain went into an overly superposed state, then it would collapse stochastically onto a more definite state. Now, take that idea, but do it with consciousness itself, because we're dualists here. Consciousness is, in fact, the primary thing that resists superposition. Consciousness can enter superpositions, but consciousness does not like being superposed. It's got a very strong tendency to collapse back to more definite states before long. And then, as that happens, then the reverse. Remember the principle connecting the physical correlates of consciousness to consciousness was a two-way street. So as consciousness collapses onto a more definite state, then the physical correlates also collapse onto a more definite state, and then thereby cause behavior. So that's how you get the effects of consciousness.
I think it's really, really beautiful, and I think there's a lot of, in consciousness, my own experience correlates with that. How does this affect like a chair or inanimate objects?
The rough idea is, okay, so just say I'm observing an external system, like a particle, which is in a superposition. Then when you look at the particle, there'll be a process that leads from the particle to your eyes. Let's say your retina is not part of the physical correlate of consciousness. When you observe a particle in superposition, then your retina will itself go into a superposition. Your retina might be in a superposition of seeing particle there and seeing particle there. Maybe your visual cortex will also go into a superposition until we reach the physical correlates of consciousness. At the point where the physical correlates of consciousness would go into superposition, then consciousness would go into superposition. But it very, very strongly resists that, according to this pole dynamics. So it goes into a more definite state. The physical correlate then goes into a more definite state. Now, that physical correlate is now heavily entangled with the state of the particle. So when the physical correlate of consciousness collapses, your visual cortex collapses, your retina collapses, the particle collapses. And that's how entanglement with effects on consciousness actually give you definite results for inanimate systems in the physical world.
Okay, and now over on their side, Ricardo.
Thank you. Maybe I'm missing something, but I've been wondering what is the relation between this role of for consciousness and the hard problem. So, I mean, it seems that here we have two jobs for consciousness. One is to make the collapse of the wave function and the quantum state. The other one is to provide the phenomenal character of our experience. And in this picture, even if it was correct, it seems to me that it would be completely fortuitous that the same principle is doing both jobs in a way. So it would be conceivable to have a zombie collapse of the wave function, but with no phenomenal character. So I'm just trying to put together the two traditional problems of consciousness.
Yeah, fair enough. Maybe I should have been more explicit. This is not intended as a solution to the hard problem in its own right. It doesn't, the collapse idea doesn't provide an answer to the question, how do physical processes give you consciousness? The dualist's answer to that is to say somehow that's primitive. There are certain fundamental laws that connect physical processes and consciousness. And in my dualist moments, I think what we have to do is find the fundamental psychophysical laws, just as we find the fundamental laws of physics. Consciousness is fundamental, but these fundamental principles will give the best explanation. In this approach, I'm basically assuming some laws in the background. So maybe Tononi's laws would say, when you've got IIT, Q shape of a certain kind, you get consciousness. I'm just taking that part of the story for granted and answering a different problem, which is the consciousness causation problem. How does consciousness play a causal role? And that's where collapse comes in. It does raise the question, which you just raised, couldn't a zombie do all that? And therefore, how is consciousness playing a role? And yes, there is a weirdly different dynamics in a zombie universe where it's not consciousness that resists superpositions, it's merely brains that resist superpositions in certain ways, and then you'd find zombies whose brains collapse wave functions and so on. What I'd say to that is, okay, that's how it could work in the zombie world, but in our world, the fundamental locus of collapse is consciousness. It's consciousness that resists superposition, that does that to the brain, it brings on behavior, and that's the best I can do for giving consciousness a causal role.
Thank you. And now on this side.
Thank you. I'm not a physicist, so I have difficulty fully understand your lecture, but I very much enjoy the text there. You mentioned that measurement is a wave function property, right? So as for consciousness, I think there is a different consciousness. Consciousness is not always the same. For example, when I try to measure the particles, that is a consciousness with very strong content in it.
It's a very...
Has a very clear content and intention in it. But I have practiced the meditation regularly in the past 6 years, and I know that it's possible to be conscious without intention. And this is a state of not only consciousness, but also a state of energy. I'm from China, so I like this. So that means in Taoism, Taoism, in an older book, it says when we rest our mind, the energy will flow in the body. That means, in that case, we are reducing the superposition, and then the wave function will be improved. So maybe next time you can have a regular meditator doing the experiment. Maybe you have different findings. Thank you.
Thank you. That is wonderful. I've been looking for empirical evidence of consciousness and superposition and resisting superposition. I've got to say, I think it's a. I mentioned that I think it's an issue for this view that it has to posit superpositions in consciousness. I'd like the absolute M property idea in some ways better, because I have never introspectively discovered my consciousness in superposition. You get things like it, double vision and blurry and vague states, but still it seems that somehow it's just a consciousness definite state with a double element. So I have never found my state of consciousness in superposition. At least on this view, they're going to be relatively small, and maybe there's a story to tell. But if you can actually find some empirical evidence for states of consciousness in superposition and mechanisms by which those superposition collapse, that would be wonderful empirical evidence for my view. So thank you.
Okay, on the other side now, please.
Yeah, thanks. So my question is, do you think that we need to go this route, this wave function collapse route, in order to solve the interaction problem? Or can we solve it another way? So here's why I think maybe we can solve it in another way. My grasp of physics is not sophisticated, but the thought's this. So why is the interaction problem a problem? Well, physics is causally closed. Well, why? Well, because, conservation of energy and momentum. Okay, in a closed system. Right? But the dualist says, well, the brain isn't a closed system. In some sense, the brain is an open system. So we don't have to say that it's causally closed and that's the end of it. So that seems to me sort of question-begging. So I'm just wondering if we can set all this aside and come up with some other mechanism that's sort of more classical.
Yeah, I think there are multiple options for the interactionist. And the collapse mechanism is just the one which seems to be positively, receive the most direct support as a possibility from physics. There's here in a fairly standard version of physics, there's a massive wide open gap that it looks like consciousness could fill. It's not the only option, and certainly, people have posited, you can always have more forces in your physics. So maybe as well as these 4 fundamental forces, there's a mental force could somehow be integrated. It will at the very least get messy. Now, I should say I do not see the interaction problem is generated by the conservation of energy. I think that's a fairly weak version of the problem. There's lots of ways interaction could happen while conserving energy. So I'm not sure the distinction between open and closed systems is the worry. The basic worry is we're going to need some dynamics, some ways that the mind affects physics that doesn't mess up standard physical laws. Maybe there are other options like new mental forces. The worry is, of course, there's absolutely no evidence for them suggested by anything in the way of physics. It would be a radical revision of physics for reasons totally extraneous to physics, whereas the collapse view at least has the possibility of being a revision, of adopting these views for reasons which are more internal to physics. But yeah, let 1,000 flowers bloom. I'm all for exploring different options too.
I see, thank you.
I'm sorry, now we're out of time and I'm having to end the question period. I'm sure Dave would be happy to talk to you later. Now, the second part of this morning's event is different in kind than usually happens here. Maybe I'm going to embarrass Dave a bit here. One of the sponsors of this conference, the Society for Mind Matter Research, wanted to recognize that Dave is perhaps the most prominent philosopher of consciousness over the last several decades, and not just in philosophy. He's had a huge influence cross-discipline. We're going back to the first talk given at the first Tucson conference, which raised the hard problem and really transformed both the philosophy and science of consciousness. I don't think I'm saying too much to say that, although he is turning a bit red there. But anyway, and so we would like to honor him. The Society has produced a nice plaque, which a very nice little memento. I would like to read the dedication. This is the Mind Matter Prize for 2019. The prize is awarded in recognition of Professor Chalmers' long-standing and influential work on the place of consciousness in nature. With his seminal notion of the hard problem of consciousness, he has contributed essentially to the rise of alternatives to physicalism in the study of consciousness from the late 20th century until today. His work emphasizes the inescapable significance of metaphysical reflection in scientific research in general and consciousness studies in particular, and it has inspired numerous scholars interested in the mind-matter relationship. So, the prize goes to David Chalmers. But the main event is still to come. We have been given access to some new and cutting-edge research at CERN, and this has enabled us to produce something really spectacular. Now, do not be alarmed if the lights might flicker. We will, for a brief time, be using all the electrical power Europe produces as we generate, using newly discovered negative energy matter, a connection to the mid-17th century, and we will be visited by René Descartes. And now I need a spotlight.
I think I am in a dream produced by my predictive brain, traveling through time 400 years to see how the cult of me, René Descartes, is doing in this time. I have heard I have a disciple, Monsieur Charmeur. Where are you, Monsieur Charmeur? I am so charmé to meet you, because so many people have tried to demolish my philosophy. All these barely human quasi soi-disant philosophes who have been yapping and barking at me. They should be locked up. And you have refuted them all, Monsieur Charmeur. I am so grateful. You have refuted them, and I do not know what other people you have refuted. But I have to say, I have also been a little disappointed. Because, well, you have had no really new ideas, and also you have plagiarized from the young man in Amsterdam, and also, oh, so many problems. Let me first say, you say consciousness is a hard problem. Consciousness is not a hard problem. You blame others, they give an easy answer to a hard problem. You, Monsieur Charmeur, you gave hard answer to easy problem. There is no problem more easy than consciousness because God has made my soul to function, thinking. That is the thinking function of my brain. And so, of course, I am conscious. There is no problem. This is a faux problem. Well, that is only the first problem. Now you have been flirting with this young Baruch who is always smoking something in Amsterdam, in whatever pipe we don't know. And now you think maybe stones have minds. Well, yes, maybe young Baruch is correct. Maybe stones all have an idea. But a stone only has one idea. I am a stone. But you see, you say, as if you found that out by yourself, that the mind is connected to the body. Évidemment. Yes. But how? It is connected by the pineal gland. And that is why you cannot talk to a stone. You cannot talk to a stone because the stone's mind is not connected with the stone body. So, I have heard that in your century, you now have philosophie expérimentale. So I suggest you put a pineal gland inside the stone. And then you listen very, very carefully. See if it tells you something. Probably only tell you I am a stone. Well, that is the first a couple of things about my disappointment, Monsieur Chalmers. I don't know whether you want to say anything in your justification for these erroneous doctrines which you are promulgating 400 years after you try to understand me and you try to get the truth. But as far as I am concerned, you have only made complicated things which are simple. You have been looking for noon at 2 o'clock.
I think maybe we can come to an agreement. We say consciousness interacts with the brain through the pineal gland.
Yes!
Because when the pineal gland enters superpositions, it collapses. The wavefunction.
Ah, that is another of these blasphemes that I have been hearing in my day. Even in dreams, every triangle has 3 sides. Even in dreams, 2 + 2 = 4. But nowadays, they say that a thing can be in 2 places at once. And they say that something can exist and not exist at the same time. So I think what is collapsing here is, well, I don't want to be rude, but I think what is collapsing maybe is somebody's pineal gland.
So René, I'm a great admirer of your philosophy.
I know I wouldn't have come as a surprise.
One of the great.
I'm almost as much of a narcissist as you. That is, through the centuries.
There was only one philosopher of your period who I admire more.
Oh.
Princess Elizabeth.
Elizabeth. Oh,
Princess Elizabeth.
Yes, of course.
I thought she really got your number on the interaction problem.
Yes, well, she didn't understand me properly.
Ah, I see.
That's I suppose what you mean by my number.
She said she would rather believe in having these effects of consciousness on extension, which are completely inexplicable. She would rather believe that consciousness itself could be material and extended. That would make more sense than your view.
Well, I have to concede that maybe God could have done it differently. But the fact is, he didn't. And I know this by the natural light of reason. Now,
Very
of course,
good.
if you reject the natural light of reason, well, then I don't know whether we could converse anymore. But in the natural light of reason, God made my soul, and I decided not to give the soul inside the matter. He put it outside the matter, and then it is in pineal gland where it revolves. Yes.
What if we're all in a simulation produced by an evil demon who is merely making you think you have a pineal gland?
That is one of the problems worst about the inadequacy of your thinking. I mean, I do not doubt that you are a thinking being. I could doubt it, but I won't. And if you are a thinking being, then you realize that necessarily you are conscious, and finalement there is no problem. But when I hear that you think that maybe underlying all the appearances, there are just bits and bytes, whoop, whoop. There is just information. Well, if it's just information, why is everybody so very ill-informed? That's only an aside. Yes, but you cannot have a difference with a substance to be different from the other substance. So, what has happened here is you have been seduced by that very evil genius that I told you how you could vanquish him.
You told me that God would never let him deceive me. God, you have failed. You're telling me now the evil demon has deceived me.
Well, yes, you,
Yeah,
yes,
okay.
that you didn't deceive me.
Very
That's
good.
the whole point. I told you what to do. And now you believe that we are only seeing appearances and the underlying reality is a difference without any substance to be different. So that obviously means that we don't really exist. And so in your very belief that you have refuted the genius has captured you. And in your very belief that you exist manifests your error, because the conclusion of your argument is that actually you don't exist.
I'm in trouble then.
Yes,
But what
trouble,
do you
yes,
say? What do you
trouble.
say? You say God would never permit there to be this evil genius who would produce these beings who are being deceived. But now we look around and we see simulation technology and virtual worlds and video games getting far more sophisticated every day, and we can put people in virtual realities that begin to look like this, and we can even deceive them. People are in these virtual realities and they don't know it, and in 50 years, we'll have better technology still. So how can you say that God would not permit this deception when the technology for this deception is all around us?
Well, between you and me, there's one thing I learned since I died. God doesn't exist. And as a matter of fact, I realize now that my ontological argument, which is one of the beautiful things I did, I got the wrong conclusion.
Ah,
Yes,
really?
because if you compare a God who is all-powerful and makes everything with another one who is all-powerful and he makes everything, but the first one has to exist, and the second one doesn't even have to bother to exist. Surely that is more powerful. If you have to exist, it's already a handicap. So, the right conclusion of the ontological argument is that God does not exist.
And you, René?
Yeah, well,
You exist?
I'm
not so sure about you.
Sometimes yes, sometimes no. Yeah, sort of your attitude to all these theories of mine. Sometimes yes, one day no. Yeah, you can't expect to believe the same thing all the time.
Surely it's not possible that you're a mere fictional entity.
Well, maybe.
I'm thinking maybe Harold Atmanspacher is an evil genius who produced a simulacrum of Descartes here to deceive me. Ah, okay,
Yes,
here's the
yes.
evil genius of Interlaken.
But you know, there's one thing you never committed yourself to.
Mm.
Do you or do you not have an immortal soul?
I would like to.
Yeah, he is shifty, isn't he?
Yeah, I would like
Very,
to.
very shifty. Doesn't
ho-
commit himself.
I hold out hopes for being uploaded one of these days.
But you know, I think that you do have an immortal soul.
Oh,
I'll
thank
tell
you.
you why, because I discover you have a new invention, the smartphone. Everybody's reading their smartphone here. Yes? And in a smartphone, you see, you have maybe 1,000 books. This is all mental stuff. And it doesn't weigh even 1 nanogram. So obviously, it is not just a little bit of spirits, you know, because with the very, very fine spirits, still after a certain amount, they start weighing you down. But this doesn't really weigh anything, and it has no extension. Therefore, the phone has a soul, and if a phone has a soul, I think you and I can probably have a soul too.
And particles?
Ah, those particles, that's a different matter because I never see them. And you see, I have made very clear that our senses are not made to understand such deep questions. They are only meant to guide us through the practical things of life. Deep down, I'm just a behaviorist pragmatist.
This is shocking.
Not,
This
not
is
very many
shocking.
people realize this. Yes. But when you look at what I say about sensation, I think you'll realize that is the proper conclusion.
So you are a behaviorist, you are an atheist, you are a neutral monist of information.
Well, you know, in 400 years you can change a lot.
Yeah, very good.
For 400 years you can progress.
I thought you just time traveled, but no, you've been waiting around and thinking.
No, I just progress very, very fast.
Oh, very good.
I time travel very, very fast.
I'm sorry, but I'm told the
I must disappear.
traversable hole is
I am-
wavering,
I think not.
and we would like
Therefore, I disappear.
Monsieur Descartes. I'm sorry, you must exit the 21st century.
I am being disappeared. And so I say, au revoir.
Cheers, René. Woo! My man Descartes. No one's given it.
Needless to say, that concludes this session, and we reconvene at 2 o'clock, I believe.